As technology relentlessly advances, so does our innate yearning for simpler, more intuitive interfaces. For years, we've marveled at the ingenuity of voice assistants and the empathy of chatbots. Yet, an unseen digital frontier lay untouched, an intuitive communion with our very own local devices. Historically, our dialogues with our personal systems have been shrouded in complexity, lines of code, specific commands, technical jargon. But what if this could change? What if our machines could understand and cater to our needs just as a fellow human might? OpenInterpreter emerges as a beacon of this transformative vision, redefining the boundaries of human-computer interaction. It isn't merely a software but a conduit, harmonizing our thoughts, desires, and commands with the vast capabilities of digital realms. It ingeniously interweaves the accuracy of code interpreters with the fluidity of text interpreters, offering an interface that's as flexible as it is powerful. The scope of OpenInterpreter is vast and unparalleled. From running nuanced scripts in Python to swiftly converting files across a spectrum of codecs, its capabilities are multifaceted. But it's not just about scripts and files. Ever imagine creating a fully functional app through a casual chat? This code creates an instance of the interpreter class from the interpreter module in Python, and then adds that instance to the sys.modules dictionary under the key interpreter. This means that when users import interpreter, they will actually get an instance of the interpreter class. This code defines a command line interface, CLI, for the OpenInterpreter Python package. The CLI function takes an instance of the interpreter class as an argument, modifies it according to command line flags, and then runs the chat method of the interpreter instance. The argparse module is used to define the command line flags that can be passed to the CLI function. The flags are Y, yes, F, fast, L, local, and D, debug. Each flag has a corresponding action and help text. For example, the Y flag has an action of store_true, which means that if the flag is present, the args.yes attribute will be set to true. After the command line flags have been defined, the parser.parse_args method is called to parse the command line arguments and set the corresponding attributes of the args object. The interpreter instance is then modified according to the command line flags. For example, if the Y flag is present, the auto_run attribute of the interpreter instance is set to true. Similarly, if the F flag is present, the model attribute of the interpreter instance is set to GPT-3.5 Turbo. Finally, the chat method of the interpreter instance is called to start the chat interface. Let's start working on the CLI part of our program. This code imports several modules from the rich package in Python. The rich package is a library for rendering rich text and beautiful formatting in the terminal. The live class is imported from the live module. This class provides a context manager for rendering live updates in the terminal. The panel class is imported from the panel module. This class provides a container for displaying rich text and other content in a bordered panel. The minimal constant is imported from the box module, and is used to specify the style of the border for the panel instance. The syntax class is imported from the syntax module. This class provides syntax highlighting for code snippets in the terminal. The table class is imported from the table module. This class provides a way to display tabular data in the terminal, with support for headers, footers, and cell styling. The group class is imported from the console module. This class provides a way to group multiple console renderables together, so that they can be displayed as a single unit. The console class is also imported from the console module. This class provides a way to interact with the terminal, including reading input, writing output, and rendering rich text. This code defines a code block class in Python. This class is used to display code and outputs in different languages. The _init_ method of the code block class initializes several instance variables. These include language, output, code, and active_line. The language variable is used to specify the programming language of the code block. The output variable is used to store the output of the code block. The code variable is used to store the code itself. The active_line variable is used to keep track of the currently active line of code. The live class is imported from the rich.live module, and is used to create a live update context for the code block. The console class is imported from the rich.console module, and is used to create a console instance for the live update context. The vertical_overflow parameter is set to visible, which means that the console will display all output, even if it exceeds the height of the console window. The start method of the live instance is called to start the live update context. This allows the code block to display live updates as the code is executed. This code defines a method called update_from_message in the code block class in Python. This method is used to update the language and code instance variables of the code block instance based on a message received from a chatbot. The message parameter is a dictionary that contains information about a function call made by the chatbot. If the message dictionary contains a function underscore call key and a parsed underscore arguments key, the parsed underscore arguments value is extracted from the dictionary. If the parsed underscore arguments value is not none, the language and code instance variables of the code block instance are updated based on the values of the language and code keys in the parsed underscore arguments dictionary. If both self.code and self.language are not none, the refresh method of the code block instance is called to update the display of the code block. This code defines a method called end in the code block class in Python. This method is used to stop the live update context for the code block and refresh the display of the code block. The refresh method of the code block instance is called with the cursor parameter set to false. This updates the display of the code block without showing the cursor. The stop method of the live instance is called to stop the live update context. This stops the display of live updates for the code block. This code defines a method called refresh in the code block class in Python. This method is used to update the display of the code block based on the current state of the code block instance. The code instance variable of the code block instance is retrieved, and if it is none, the method returns without doing anything. A table instance is created to display the code. The table is configured to not show a header or footer, and to expand to fill the available space. A single column is added to the table. If the cursor parameter is true, a cursor is added to the end of the code. The code is then split into lines, and each line is added to the table as a row. If the line is the active line, as determined by the active underscore line instance variable, it is displayed with a white background and a black foreground. Otherwise, it is displayed with a monokai theme. A panel instance is created to display the code table. The panel is configured to use a minimal border and a dark background. If the output instance variable of the code block instance is not empty, a panel instance is created to display the output. The panel is configured to use a minimal border and a light background. A group instance is created to group the code panel and the output panel together. This group is used to display both panels side by side. The update method of the live instance is called with the group instance as an argument to update the live display of the code block. The refresh method of the live instance is then called to refresh the display of the code block. Now we have an interface we can start working on the code interpreter. This code imports several modules in Python, including subprocess, web browser, tempfile, threading, traceback, platform, time, ast, aster, sys, and os. These modules provide a variety of tools for working with subprocesses, opening web browsers, working with temporary files, running threads, handling exceptions, getting information about the platform, working with abstract syntax trees, and interacting with the operating system. The subprocess module is used to spawn new processes, connect to their input/output/error pipes, and obtain their return codes. The web browser module is used to open web browsers to display HTML content. The temfile module is used to create temporary files and directories. The threading module is used to create and manage threads of execution. The traceback module is used to print or retrieve a stack traceback for an exception. The platform module is used to retrieve information about the platform the code is running on. The time module is used to work with time values. The ast module is used to work with abstract syntax trees of Python code. The aster module is used to generate Python code from an abstract syntax tree. The sys module provides access to some variables used or maintained by the interpreter and to functions that interact strongly with the interpreter. The os module provides a way of using operating system-dependent functionality like reading or writing to the file system. This code defines a function called run_html in Python. This function is used to display HTML content in the user's default web browser. The HTML_content parameter is a string that contains the HTML content to be displayed. A temporary file is created using the tempfile.name temporary file method. The delete equals false parameter ensures that the temporary file is not deleted when it is closed. The suffix equals HTML parameter sets the file extension to HTML. The HTML content is written to the temporary file using the write method of the file object. The web browser.open method is used to open the temporary HTML file in the user's default web browser. The os.path.realPath method is used to get the full path of the temporary file, and the file // protocol is used to specify that the file should be opened as a local file. The function returns a string that indicates that the temporary file has been saved and opened in the user's default web browser. This code defines a dictionary called language_map in Python. This dictionary maps programming languages to their start, run, and print commands. The keys of the language_map dictionary are strings that represent the names of programming languages. The values of the dictionary are themselves dictionaries that contain two keys, start_cmd and print_cmd. The start_cmd key maps to a string that represents the command used to start the interpreter for the programming language. The print_cmd key maps to a string that represents the command used to print output from the interpreter. The language_map dictionary contains mappings for several programming languages, including Python, Shell, JavaScript, and AppleScript. For each language, the start_cmd and print_cmd values are set to appropriate commands for that language. For example, for Python, the start_cmd value is set to sys.executable plus IQU, which starts the Python interpreter in interactive, quiet, and unbuffered mode. The print_cmd value is set to print, which is the command used to print output from the Python interpreter. In addition to the programming languages mentioned above, the language_map dictionary also contains a mapping for HTML. For HTML, the open_subprocess value is set to false, indicating that the HTML content should not be run as a subprocess. Instead, the run_function value is set to run_html, which is a function defined elsewhere in the codebase that is used to display HTML content in the user's default web browser. This code defines a class called CodeInterpreter in Python. This class is used to display and run code in different programming languages. The _init_ method of the CodeInterpreter class takes two parameters, language and debug_mode. The language parameter is a string that represents the programming language to be used. The debug_mode parameter is a boolean that indicates whether debug mode is enabled. The start_process method of the CodeInterpreter class is used to start a subprocess that will execute the code. The method retrieves the start_cmd value for the selected programming language from the language_map dictionary, which maps programming languages to their start, run, and print commands. The subprocess.open method is used to start the subprocess. The start_cmd value is split into a list of arguments using the split method, and these arguments are passed to the popen method. The stin, stout, and str parameters are set to subprocess.pipe, which allows the code to read from and write to the standard input, output, and error streams of the subprocess. The text parameter is set to true, which indicates that the streams should be treated as text rather than bytes. The buf size parameter is set to 0, which indicates that the streams should be unbuffered. Two threads are started to watch the standard output and error streams of the subprocess. The save_and_display_stream method is called for each thread, passing the appropriate stream and a boolean indicating whether the stream is an error stream. This method reads lines from the stream and saves them to a list, which is used to display the output in real time. This code defines a method called update_active_block in the CodeInterpreter class in Python. This method is used to update the display of the active code block with the current output and active line number. The output attribute of the CodeInterpreter instance is truncated using the truncate_output function. This function is defined elsewhere in the codebase and is used to limit the amount of output that is displayed in the code block. The active_line and output attributes of the CodeInterpreter instance are assigned to the active_line and output attributes of the active_block attribute of the CodeInterpreter instance. The active_block attribute represents the currently active code block in the user interface. The refresh method of the active_block attribute is called to update the display of the code block with the new active_line and output attributes. This code defines a method called run in the CodeInterpreter class in Python. This method is used to execute code in the selected programming language. The code attribute of the CodeInterpreter instance is set to the code of the active code block. The active_block attribute represents the currently active code block in the user interface. The forbidden commands list is commented out, but it appears to be a list of commands that are not allowed to be executed. If any of these commands are found in the code, an error message is displayed and the method returns. The open_subprocess variable is set to the open_subprocess value for the selected programming language from the language_map dictionary, which maps programming languages to their start, run, and print commands. This variable indicates whether a subprocess should be kept open for the selected programming language. If a subprocess has not been started and open_subprocess is true, the start_process method is called to start the subprocess. If an error occurs while starting the subprocess, the traceback is displayed as output and the method returns. The output attribute of the CodeInterpreter instance is reset to an empty string. The print_cmd attribute of the code interpreter instance is set to the print_cmd value for the selected programming language from the language_map dictionary. This attribute is used to add print commands that tell us what the active line is. If the print_cmd attribute is not none, the add_active_line_prints method is called to add print commands to the code that tell us what the active line is. If an error occurs while adding the print commands, the traceback is displayed as output and the method returns. If the selected programming language is Python, the wrap_in_try_except function is called to wrap the code in a try-except block. This allows us to stop execution when an error occurs and solves indentation problems. Any whitespace lines are removed from the code, as this will break indented blocks. If the print_cmd attribute is not none and the selected programming language is not AppleScript, an end command is added to the code. This is used to indicate when the code is finished executing. If the selected programming language is AppleScript, the code is processed in a special way. Double quotes are escaped, the code is wrapped in double quotes, and a start command and end command are added. If debug mode is enabled, the code is printed to the console. If the selected programming language is HTML, the run_function for HTML is called to run the code. The done attribute of the code interpreter the instance is reset and cleared. This attribute is used to indicate when the code is finished executing. The code is written to the standard input of the subprocess using the st.write method. If a broken pipe error occurs, the start_process method is called again and the run method is called recursively. The done.wait method is called to wait until the code has finished executing. Before the method returns, a delay of 0.1 seconds is added to allow the display to catch up. The output of the code is returned as a string. This code defines a method called add_active_line_prints in the code interpreter class in Python. This method is used to add print statements to the code that indicate the active line number during execution. The code parameter is a string that represents the code to be modified. If the selected programming language is Python, the add_active_line_prints_to_Python function is called to add print statements to the code. This function is defined elsewhere in the codebase and is used to add print statements to Python code. If the selected programming language is Shell, the code is checked for breaking cases. If the code has more than one line, or if it contains a for, do, or done keyword, or if any line starts with whitespace, the original code is returned. This is because the add_active_line_prints method struggles with these cases in Shell. If the selected programming language is not Python or Shell, the code is split into lines using the split method. An empty list called modified_code_lines is initialized to hold the modified lines of code. The method iterates over each line in the original code. For each line, it finds the leading whitespace of the next non-empty line using a nested loop. It then formats a print command with the current line number in the found leading whitespace, and adds the print command in the original line to the modified lines. The modified lines are joined with new lines using the join method, and the result is returned. This code defines a method called save_and_display_stream in the code interpreter class in Python. This method is used to handle the output of a subprocess that is executing code in the selected programming language. The stream parameter is a file-like object that represents the output of the subprocess. The is_error_stream parameter is a boolean that indicates whether the output is an error stream. The method iterates over each line of output in the stream object using the readline method. For each line, it performs several checks and updates the output and active_line attributes of the code interpreter instance. If debug mode is enabled, the line of output is printed to the console. If the selected programming language is JavaScript, the line of output is checked for certain messages that are not relevant to the user. If any of these messages are found, the line is skipped. If the selected programming language is Python, the line of output is checked for certain messages that are not relevant to the user. If any of these messages are found, the line is skipped. If the line of output starts with active_line, the active_line attribute of the code interpreter instance is set to the line number indicated in the message. If the line of output contains end_of_execution, the done attribute of the code interpreter instance is set to indicate that the code is finished executing. If the is_error_stream parameter is true and the line of output contains keyboard interrupt, keyboard interrupt, the exception is raised. Otherwise, the line of output is added to the output attribute of the code interpreter instance, and the update_active_block method is called to update the display of the active code block. This code defines a function called truncate_output in Python. This function is used to truncate the output of a subprocess that is executing code in the selected programming language. The data parameter is a string that represents the output of the subprocess. The max_output_chars variable is set to a fixed value of 2000 characters. This value represents the maximum number of characters that will be displayed in the output. The message variable is set to a string that represents a message that will be displayed if the output is truncated. This message includes the number of characters that will be displayed in the output. The function first checks if the output already contains a previous truncation message. If it does, the message is removed and the needs_truncation variable is set to true. If the length of the output exceeds the max_output_chars value or needs_truncation is true, the output is truncated to the last max_output_chars characters and the message is added to the beginning of the output. The truncated output is returned by the function. This code defines a class called addLinePrints in Python. This class is used to insert print statements into the abstract syntax tree, AST, of a program that indicate the line number before every executable line. The insert_print_ statement method is used to insert a print statement for a given line number. This method returns an ask.exp object that represents the print statement. The ask.exp object contains an ask.call object that represents the call to the print function. The ask.name object with the ID attribute set to print represents the name of the function being called. The ask.constant object with the value attribute set to active_line, line_number, represents the argument being passed to the function. The addLinePrints class is a subclass of AST.NoTransformer, which is a built-in class in Python's AST module. This class is used to modify the AST of a program by traversing the tree and applying transformations to each node. This code defines a method called process_body in the code interpreter class in Python. This method is used to process a block of statements and add print statements to indicate the line number before every executable line. The body parameter is a list of AST nodes that represent the statements to be processed. The method initializes an empty list called new_body to hold the modified statements. The method iterates over each node in the body list. For each node, it checks if the node has a line_no attribute. If it does, the insert_print_ statement method is called to insert a print statement for the line number of the node. The resulting ask.exp object is appended to the new_body list. The original node is then appended to the new_body list. The modified new_body list is returned by the method. This code defines a method called visit in the addLinePrints class in Python. This method is used to traverse the abstract syntax tree, AST, of a program and apply transformations to each node. The node parameter is an AST node that represents a statement or expression in the program. The method first calls the visit method of the superclass, AST.NoTransformer, to visit the children of the node and apply any transformations to them. If the node has a body attribute, the process_body method is called to process the body of the node. The resulting modified body is assigned to the body attribute of the node. If the node has an or-else attribute and it is not empty, the process_body method is called to process the or-else block of the node. The resulting modified or-else block is assigned to the or-else attribute of the node. If the node is an instance of ask.try, the process_body method is called to process the body, handlers, and final body blocks of the node. The resulting modified blocks are assigned to the corresponding attributes of the node. The modified node is returned by the method. This code defines a function called add_active_line_prints_to_Python in Python. This function is used to add print statements to a Python code string that indicate the line number before every executable line. The code parameter is a string that represents the Python code to be modified. The function first uses the AST module to parse the code string into an abstract syntax tree, AST, that represents the structure of the code. The addLinePrints class is then instantiated to create a transformer object that can modify the AST of the code. The visit method of the transformer object is called to traverse the AST of the code and apply transformations to each node. The addLinePrints class overrides the visit method to insert print statements for the line numbers of executable lines. The resulting modified AST is then unparsed back into a string using the ask.unparse method. The modified code string is returned by the function. This code defines a function called wrap_and_try_except in Python. This function is used to wrap a block of code in a try-except block that catches and prints any exceptions that occur during execution. The code parameter is a string that represents the code to be wrapped. The function first adds an import statement for the traceback module to the beginning of the code string. The AST module is then used to parse the code string into an abstract syntax tree, AST, that represents the structure of the code. A try object is created with the body attribute set to the body of the parsed code, and an except handler object is created with the type attribute set to exception and the body attribute set to a single exp object that calls the print_exp method of the traceback module. The try object is then assigned to the body attribute of the parsed code, effectively wrapping the entire code in a try except block. The modified AST is then unparsed back into a string using the as.unparse method. The modified code string is returned by the function. Now to understand the sentences, we will use llama 2. Let's code it. This code imports several Python modules that are used in the llama_2.py file. The us module provides a way to interact with the operating system, such as accessing environment variables and running system commands. The sys module provides access to some variables used or maintained by the Python interpreter and to functions that interact strongly with the interpreter. The j module provides a way to download files from the internet. The ipters module provides a way to access standard application directories for user-specific data, such as configuration files and cache data. The inquirer module provides a way to create interactive command line user interfaces. The subprocess module provides a way to spawn new processes, connect to their input/output/error pipes, and obtain their return codes. The context_lib module provides utilities for working with context managers, which are objects that define a runtime context that can be used with the with statement. The rich module provides a way to create rich text output in the terminal, including support for colors, styles, and tables. This code defines a function called get_llama_2_ instance in Python. This function is used to prompt the user to select a model size for the code llama interpreter, which is used for local code execution. The function first defines a dictionary called models that contains information about the available models for the code llama interpreter. Each model has a name, 7b, 13b, or 34b, and 3 different parameter sizes, low, medium, or high, each with a corresponding URL, size, and RAM usage. The inquirer module is then used to create a command line interface that prompts the user to select a parameter size for the model. The available parameter sizes are determined by the keys of the model's dictionary. The user's selection is stored in the chosen_param variable. This code is part of the llama_2.py file and defines a function called get_llama_2_ instance in Python. This function is used to prompt the user to select a quality level for the code llama interpreter, which is used for local code execution. The function first defines a dictionary called models that contains information about the available models for the code llama interpreter. Each model has a name, 7b, 13b, or 34b, and 3 different parameter sizes, low, medium, or high, each with a corresponding URL, size, and RAM usage. The inquirer module is then used to create a command line interface that prompts the user to select a quality level for the model. The available quality levels are determined by the keys of the model's dictionary. The user's selection is stored in the chosen_quality variable. The function then prompts the user to confirm whether they want to use a GPU for the code llama interpreter. If the user confirms, the n_pu_layers variable is set to -1, otherwise it is set to 0. The URL for the selected model and quality level is then retrieved from the model's dictionary. The function then determines the user data directory and creates a default path for the code llama interpreter model files. The function checks for the existence of the model file in several directories, including the default path and several other possible locations. If the file is found, the model_path variable is set to the path of the file. If the file is not found, the function prompts the user to confirm whether they want to download the file. If the user confirms, the file is downloaded to the default path and the model_path variable is set to the path of the downloaded file. Finally, the function attempts to import the llama class from the llama_cpp module. If the import fails, the function prompts the user to confirm whether they want to install the llama cpp Python package. If the user confirms, the package is installed. This code defines a function called check_command in Python. This function is used to check whether a command can be executed in the current environment. The command parameter is a string that represents the command to be executed. The function uses the subprocess module to run the command and capture its output and error streams. If the command executes successfully, i.e., returns a 0 exit code, the function returns true. If the command fails to execute, i.e., returns a non-zero exit code, the function returns false. The function also handles two exceptions that may occur during execution: subprocess.called process error and file not found error. If either of these exceptions is raised, the function returns false. This code defines a function called install_llama in Python. This function is used to install the llama CPP Python package using pip, with optional arguments to specify the backend for the CodeLlama interpreter. The backend parameter is a string that represents the backend to be used for the CodeLlama interpreter. The available options are kublas, hiplas, metal, or any other string, which defaults to OpenBLAS. The function first creates a dictionary called env_vars that contains environment variables to be passed to the subprocess.run method. The force_make variable is set to 1 to force the use of make during installation. If the backend parameter is set to kublas, hiplas, or metal, the corresponding make_args variable is set to enable the use of the specified backend. Otherwise, the make_args variable is set to enable the use of OpenBLAS. The subprocess.run method is then used to execute the pip install command for the llama CPP Python package, passing the env_vars dictionary as environment variables. If the command executes successfully, i.e., returns a 0 exit code, the function completes without error. If the command fails to execute, i.e., returns a non-zero exit code, the function prints an error message to the console. This code defines a function called supports_metal in Python. This function is used to check whether the current system supports the use of the metal backend for the CodeLlama interpreter. The function first checks whether the current system is running macOS by checking the value of the platform.system function. If the system is not macOS, the function returns false. If the system is macOS, the function retrieves the version number of the operating system using the platform.mac_var function. The version number is split into a tuple of integers using the map and int functions. The function then checks whether the version number is greater than or equal to 10, 11, which is the minimum version required for metal support. If the version number is greater than or equal to 10, 11, the function returns true. Otherwise, the function returns false. This code is part of the llama_2.py file and defines a function called get_llama_2_ instance in Python. This function is used to prompt the user to select a quality level for the CodeLlama interpreter, which is used for local code execution. The function first defines a dictionary called models that contains information about the available models for the CodeLlama interpreter. Each model has a name, 7b, 13b, or 34b, and 3 different parameter sizes, low, medium, or high, each with a corresponding URL, size, and RAM usage. The Inquirer module is then used to create a command line interface that prompts the user to select a quality level for the model. The available quality levels are determined by the keys of the model's dictionary. The user's selection is stored in the chosen_quality variable. The function then prompts the user to confirm whether they want to use a GPU for the CodeLlama interpreter. If the user confirms, the n_pu_layers variable is set to -1, otherwise it is set to 0. The URL for the selected model and quality level is then retrieved from the model's dictionary. The function then determines the user data directory and creates a default path for the CodeLlama interpreter model files. The function checks for the existence of the model file in several directories, including the default path and several other possible locations. If the file is found, the model_path variable is set to the path of the file. If the file is not found, the function prompts the user to confirm whether they want to download the file. If the user confirms, the file is downloaded to the default path and the model_path variable is set to the path of the downloaded file. The function then checks the system capabilities to determine which backend to use for the CodeLlama interpreter. If the system has an NVIDIA GPU, the kublas backend is used. If the system has an AMD GPU, the hiplas backend is used. If the system is running macOS and supports the Metal API, the Metal backend is used. Otherwise, the OpenBLAS backend is used. The llama_CPP module is then imported, and an instance of the llama class is created using the model_path and n_pu_layers variables. Finally, the function checks whether the system is running macOS on an Apple Silicon M1 processor, and prints a warning message if so. The message provides instructions for installing the correct version of Python to support the ARM64 architecture. This code is part of the llama_2.py file and defines a function called confirm_action in Python. This function is used to prompt the user to confirm an action by answering a yes or no question. The function takes a single parameter called message, which is a string that represents the question to be asked. The inquirer module is used to create a command line interface that prompts the user to answer the question with a yes or no response. The default response is set to true, which means that the user will be prompted to confirm the action by default. The user's response is stored in the answers dictionary, and the value of the confirm key is returned as a Boolean value. Now let's code the normal interpreter. This code is part of the interpreter.py file and imports several modules and functions used by the code interpreter program. The CLI module is imported to provide command line interface functionality for the program. The utils module is imported to provide utility functions for parsing JSON and merging JSON deltas. The message block and code block classes are imported to provide functionality for formatting and displaying messages and code blocks in the program's output. The code interpreter class is imported to provide the main functionality of the program, including executing code and generating output. The get_llama_2_ instance function is imported from the llama_2 module to provide an instance of the code llama interpreter for local code execution. The us module is imported to provide operating system functionality, such as file and directory operations. The time module is imported to provide time-related functionality, such as measuring the execution time of code. The JSON module is imported to provide JSON parsing and serialization functionality. The platform module is imported to provide information about the current platform, such as the operating system and processor architecture. The OpenAI module is imported to provide access to the OpenAI API for executing code and generating output. The getPass module is imported to provide functionality for getting the user's password from the command line. The requests module is imported to provide HTTP request functionality for accessing web resources. The redline module is imported to provide command line editing and history functionality. The ordeep.parse module is imported to provide URL parsing and encoding functionality. The token trim module is imported to provide functionality for trimming access tokens for security purposes. The rich module is imported to provide rich text formatting functionality for the program's output, such as colored text and markdown formatting. This code is part of the interpreter.py file and defines a function schema for the run_code function, which is used to execute code on the user's machine and return the output. The function schema is defined as a JSON object that specifies the name, description, and parameters of the function. The name property specifies the name of the function, which is run_code. The description property provides a brief description of the function, which is that it executes code on the user's machine and returns the output. The parameters property is an object that specifies the parameters of the function. The type property specifies that the parameters are of type object. The properties property is an object that specifies the properties of the object type. The language property is a string that specifies the programming language of the code to be executed. The code property is a string that specifies the code to be executed. The required property is an array that specifies which properties are required, which in this case are language and code. The missing_API_key_message variable is a string that provides a message to be displayed when the user does not have an OpenAI API key. The message prompts the user to provide an API key to use the GPT-4 functionality, or to press enter to use the free but less capable code llama functionality. The confirm_mode_message variable is a string that provides a message to be displayed when the user runs the Open Interpreter program. The message informs the user that the program will require approval before running code, and provides instructions for bypassing this approval step using the Y flag. The message also provides instructions for exiting the program using Ctrl+C. This code is part of the interpreter.py file and defines a class called interpreter in Python. This class is used to represent an instance of the Open Interpreter program, which is a command line interface for executing code and generating output. The _init_ method is a special method that is called when a new instance of the interpreter class is created. This method initializes several instance variables that are used by the program. The messages variable is a list that stores the messages generated by the program. The temperature variable is a float that represents the temperature parameter used by the OpenAI API for generating text. The API_key variable is a string that represents the user's OpenAI API key, which is used for accessing the OpenAI API. The auto_run variable is a boolean that determines whether the program should automatically run code without user confirmation. The local variable is a boolean that determines whether the program should use the code llama interpreter for local code execution, rather than the OpenAI API. The model variable is a string that represents the name of the OpenAI API model to use for generating text. The debug_mode variable is a boolean that determines whether the program should run in debug mode, which provides additional output for debugging purposes. The system_message variable is a string that represents the default system message to display when the program starts. The code_interpreters variable is a dictionary that stores instances of the code interpreter class for each programming language. The active_block variable is an instance of the message block or code block class that represents the currently active message or code block in the program's output. The llama_instance variable is an instance of the llama class that represents the code llama interpreter for local code execution. This code is part of the interpreter.py file and defines a method called cli in Python. This method is used to create a command line interface for the OpenInterpreter program. The cli method takes the current instance of the interpreter class as an argument, modifies it according to command line flags, and then runs the chat method. The cli method uses the click module to define command line options and arguments for the program. The click.option decorator is used to define options, such as the debug flag for enabling debug mode, and the API key flag for specifying the user's OpenAI API key. The click.argument decorator is used to define arguments, such as the programming language and code to be executed. The cli method also uses the setEtr function to set instance variables of the interpreter class based on the command line options and arguments. For example, the setEtr function is used to set the debug_mode instance variable to true if the debug flag is specified. Once the command line options and arguments have been processed, the chat method is called to start the program. This code is part of the interpreter.py file and defines a method called get_info_for_system_message in Python. This method is used to generate a system message that provides information about the user and the program, as well as recommended procedures for completing the task at hand. The get_info_for_system_message method first initializes an empty string called info, which will be used to store the system message. The method then retrieves information about the user's operating system, current working directory, and username using the platform.system, os.get, and getPass.getUser functions, respectively. This information is added to the info string using string concatenation. If the local instance variable of the interpreter class is false, the method queries the Open Procedures database to find relevant procedures based on the last two messages content or function call. The relevant procedures are then appended to the info string using string concatenation. If the local instance variable of the interpreter class is true, the method adds a message to the info string that explains how to run code using the code llama interpreter. Finally, the info string is returned by the method. This code is part of the interpreter.py file and defines two methods called reset and load in Python. These methods are used to manage the program's output messages. The reset method is used to clear the program's output messages and code interpreters. It does this by setting the message's instance variable to an empty list, and the code_interpreter's instance variable to an empty dictionary. The load method is used to load a list of messages into the program's output. It takes a single parameter called messages, which is a list of message block and code block instances that represent the messages to be loaded. The load method sets the message's instance variable to the messages parameter, effectively replacing the program's current output with the new messages. This code is part of the interpreter.py file and defines a method called chat in Python. This method is used to start an interactive chat with the user, where the user can input messages and receive responses from the program. The chat method first checks whether the program is running in local mode or using the OpenAI API. If the program is running in local mode, it sets the model instance variable to CodeLlama and attempts to find or install the CodeLlama interpreter. If the CodeLlama interpreter cannot be found or installed, the program switches to using the GPT-4 language model. The chat method then displays a welcome message that includes information about the current mode and model being used, as well as instructions for how to run the program locally. If the program is not running in autorun mode, the welcome message also includes a confirmation message that asks the user for permission to run code. If the message parameter is passed to the chat method, the program responds non-interactively by adding the message to the program's output messages and calling the respond method. If the message parameter is not passed to the chat method, The program starts an interactive chat loop that prompts the user for input using the input function. The user's input is added to the program's output messages, and the respond method is called to generate a response. The chat loop continues until the user enters a keyboard interrupt or end-of-file character. This code is part of the interpreter.py file and defines a method called verify_API_key in Python. This method is used to check whether the program has an OpenAI API key, and if not, prompt the user to enter one. The verify_API_key method first checks whether the API_key instance variable of the interpreter class is none. If it is, the method checks whether the OpenAI_API_key environment variable is set. If the environment variable is set, the API_key instance variable is set to its value. If the API_key instance variable is still none, the method prints a welcome message and prompts the user to enter an OpenAI API key. If the user presses enter without entering a key, the program switches to using the CodeLlama interpreter by setting the local instance variable to true. If the user enters an API key, the API_key instance variable is set to the key. Finally, the OpenAI.API_key variable is set to the value of the API_key instance variable. This code is part of the interpreter.py file and defines a method called end_active_block in Python. This method is used to end the currently active block of code or message. The end_active_block method first checks whether the active_block instance variable of the interpreter class is not none. If it is not none, the method calls the end method of the active block to finalize it. The end method is defined in the message block and code block classes, and is used to add the block to the program's output messages. After the active block has been ended, the active_block instance variable is set to none. The code above is a Python implementation of an interpreter that can run code in multiple programming languages. The interpreter is designed to work with a language model, which is used to generate responses to user input. The interpreter is capable of handling function calls, parsing function arguments, and running code in the specified language. The respond function is the main entry point for the interpreter. It takes user input, generates a system message, and passes the input to the language model. The function then processes the response from the language model, checking for function calls and parsing function arguments as necessary. If a function call is detected, the interpreter creates a new code interpreter object for the specified language and runs the code. The output of the code is then appended to the messages list and the respond function is called again to process the next input. The code interpreter class is responsible for running code in the specified language. It takes a code block object as input, which contains the code to be run. The run method of the code interpreter class executes the code and captures the output. The output is then stored in the output attribute of the code block object. The code block class is used to represent a block of code. It contains attributes for the language of the code itself, and the output of the code. The update_from_message method of the code block class is used to update the attributes of the code block object based on the contents of a message. And finally, let's create the test methods for our project. The code above is a Python test script for the interpreter. The script imports the interpreter module and sets some configuration options for the interpreter, such as enabling auto-run mode and setting the language model to GPT 3.5 Turbo. The script defines several test functions, each of which uses the interpreter module to simulate a conversation with the interpreter and verify that it produces the expected output. The test_hello_world function tests whether the interpreter can correctly respond with the string hello, world, when prompted to do so. The test_math function tests whether the interpreter can correctly perform a multiplication operation and return the integer result. The test_delayed_exec function tests whether the interpreter can correctly execute a block of code that prints two messages with a 1-second delay between them. The test_nested_loops_and_multiple_new lines function tests whether the interpreter can correctly execute nested for loops in both Python and Shell, with multiple new lines between each line of code. The test_markdown function tests whether the interpreter can correctly handle various markdown features, such as fenced code blocks, tables, and headers.